In this video, we'll do an example of an increasing perpetuity of the continuous nature, but the ideas will hold for increasing perpetuity immediate or due. So I'll step off and let you pause and copy. All right, so this perpetuity makes payments at a rate of 1,000 per year in the first year, 1,050 per year in the second year, 1,100 per year in the third year, etc. So since they say rate of 1,000, that's the clue that it's a continuous annuity instead of just 1,000 at the beginning or at the end. We want to know the present value of the annuity, and we're told that the nominal rate of interest is 7% convertible quarterly. Okay, so the rates are given in per year, so that means the time interval we're going to be using is 1 year. And if you think about the increasing perpetuity continuous formula that we had from the previous video, you'll know we'll need the per year discount rate and the per year force of interest. So over on the side, I'm going to calculate D and delta for a 1 year period. So I know my nominal rate quarterly is 7%, and I've got a conversion. 4 quarters worth of growth is the same as 1 year of growth via discount, or 1 year of growth via a force of interest. So if I plug in 0.07 for the I4 and solve each of these equations separately, I get a D, a discount rate of 6.7041, and a force of interest of 6.9395%. Both of those are annual. So I'll be using those at various stages here. Okay, so taking the cash rates they told us and placing them in the time value diagram, those are the bottom amounts, 1,000, 1,050, 1,100, etc. It's the original perpetuity. I noticed that the original perpetuity is going up by a rate of 50 per year. So if I'm going to do an increasing perpetuity, I want it to be 1 times 50, 2 times 50, 3 times 50, because that's what the formula from the previous video can handle. X is the rate of increase, 50 bucks per year, and I start with 1 times X. All right, so that 1 times 50, 2 times 50, 3 times 50 is forced upon me by the formula that I know. So the middle line is a perfect increasing perpetuity continuous. Now, that only accounts for 50 of the 1,000 bucks, so there's 950 that I haven't accounted for during the first year. Second year, I've accounted for 100 of the 1,050, so there's still 950 unaccounted for, and that's the case every single year. So I also have a level perpetuity continuous paying in at a rate of 950 per year. Bam. So the bottom line is the sum of the 2 top rows. All right? So if I want the present value of the perpetuity, I'm going to figure out the present value of the increasing perpetuity, this middle line, plus the present value of the level perpetuity continuous, which is this top line of payments. All right? Here's the notation for each of those. I've got 50 for my X. I've got 950 for my X and my level perpetuity. There's my notation. Here is the formula for an increasing perpetuity continuous as present value. And here's the formula for an increasing perpetuities, a level perpetuity continuous as present value. I have delta and D from our work on the side. So I get 2 there. And if I stick with the decimals as shown, I got a value of 24,437.10. And now if you're off by a matter of 15, 20 cents, probably not a big deal, especially on exam FM, the separations and answers are significantly more than that. All right.